So glad to be here, to speaking with everyone about this project. I'm looking forward to your questions as well. In more than 3 decades, in 3 decades, MAP has designed over 100 multifamily units with a practice that's dedicated to design that improves the lives of others. Sustainability has always been fundamental to our work. We are humbled to have this opportunity to present to you this project, Highbridge, which is a new construction, all-electric passive house building containing affordable, supportive, and transitional shelter housing. Highbridge is one of our group of NYSERDA Buildings of Excellence demonstration projects. This is about 25% of our new construction portfolio since 2019. The BOE award program leverages competition to increase market participation in the conversations we need to be having to figure out how to cost effectively get all of our projects to be passive house. As a result of these types of efforts, the comfort level with passive house in our industry has been expanding rapidly. About 75% of our projects on the boards or in construction are now passive house, and 100% electric. This is a significant change even from just a few years ago, and we see similar numbers among our colleagues across the industry here in New York City. Highbridge is a winner from round 3, announced in March 2023. We are presenting this project to you as a case study in how to achieve an all-electric passive house design and the benefits of passive house to achieve 100% renewable grid, powering buildings that have no on-site fossil fuel combustion except for a generator. We would like to acknowledge some of the key members of our team here. All of them are too many to list, but we did want to mention, of course, the owner, Samaritan Daytop Village, the MEP engineer, Dagger Engineering, structural engineer, Gates, energy and passive house consultant, Bright Power, contractor, Mega, and landscape designer, Terrain, NYC. I'll now pass the presentation to Lara, who will share with you the design of the project. Lara is our fearless project manager, and I serve as an advisory role as Director of Sustainability for the firm. In the second half of the presentation, I'll return to describe the systems of the building and a bit more about passive house in the context of our energy transition.
Thank you, Sarah. The Highbridge is a new construction of a 32-story development in the Bronx. It is set on a steep 71,000 square feet site overlooking the Harlem River and adjacent to the New York City Highbridge Park and the Highbridge Aqueduct. This building will create 400,000 square feet of affordable and supportive housing, as well as transitional housing for families, with extensive and thoughtful programming and common spaces to serve up to 1,000 of the most vulnerable New Yorkers. As proposed, the building massing is as of right per the New York City zoning resolution. As you can see in this render, the site has a very challenging slope, but we think it's also an opportunity. The building is perched atop of the bridge that runs through the Highbridge and Morris Heights, looking down into the valley below. It has a mix of 3 different programs. The western part of the building contains 316 units of permanent housing, with a mix of affordable and supportive units. They're organized in a tower and providing studios, 1, 2, and 3 bedroom units, as well as amenity spaces and access to outdoor spaces. The eastern part of the building contains 106 units of family shelter, including 0 bedroom enlarged, and 2 bedroom units, as well as a variety of amenities, outdoor spaces, and supportive offices at the ground floor. There are also cooling centers provided per each of the programs, and amenities and community rooms are distributed throughout the building for the use of the residents. The building will offer as well a community facility space for the residents and the neighborhood. The final program is still to be determined and will potentially be either a daycare or a healthcare facility. As mentioned before, the surface of our site is a slope grade, with a very pronounced difference in elevation of 67 feet between the existing ground at the main entrance level at University Avenue. Here we can see the 137 elevation and the subcellar 5 or parking level, which is at ground level at Undercliff Avenue with an elevation of 70 feet. Besides the challenge of the steepness of the site has a high top of rock elevation with bedrock starting at depths between 9 and 18 feet, which is described in the geotechnical report as generally very hard quartz, mica, and ice bedrock. Additional to this, there is also an underground concrete line, 14 feet wide storm sewer tunnel that runs underneath the project site, east to west, and it's part of the Croton Aqueduct structure. You can see here the area of influence marked in red. MAP has been working with a team of consultants to address how to design and build a high-rise building in this site without compromising the underground storm sewer and avoiding its zone of influence as determined by DEP. We've worked closely with the GC and the structural engineer to determine the most appropriate foundation systems. Based on the preliminary geotechnical investigation, the foundation of the building will be a series of deep piles with pile caps, grade beam foundation walls, and a mat slab. The building is situated along the Highbridge Park, and the design with the building massing and the landscape strives to connect the project with the larger green corridor. The large size of the site provides a series of welcoming green outdoor spaces, including a continuous trail loop around the site, going up and down that will promote access to nature, exercise, and interaction with other residents to foster community. Biophilic design is not only incorporated around the building, but also at multiple landscape terraces throughout the building. Here where residents will have access to green spaces. As you can see in this render, the landscape design connects with the Highbridge Park that you can see behind the building and the entrance to the aqueduct, where the residents can cross to Harlem. There are 3 terraces distributed at 1st, 2nd, and 8th levels, and they offer opportunities for both passive and active recreation for all ages and abilities, including, for example, play equipment, an urban farm, chicken coop, and spaces for community activities and healthy food workshops. The laundry rooms for both the permanent and for the transitional housing programs are specifically designed connected to these terraces and also to the kids' playroom. Here we can see a series of renderings showing some of those landscape amenity areas. Starting bottom left, we can see the open space at grade that connects the building entrance with the exercise loop and walking trails. Bottom right, we can see a snip of how that terrace at ground floor for the shelter area will have a space that is open to the sky and a part that is covered with the shelter floors above. At the top right, this is the terrace on the 2nd floor that we will be talking a little bit more in the next slides, where permanent residential and shelter programs mix. And the top left, we have a partial view of the 8th floor terrace overlooking the aqueduct, the river, and the city. This terrace will contain several of the amenities mentioned before for the permanent residents, like urban farming garden, chicken coop, and spaces for community building activities and workshops. Embracing the high visibility of this development, the design is meant to offer a counterpoint commensurate with the iconic Highbridge water tower on the Manhattan side of the river. All the 3 programs have their main entrance at University Avenue. Residential to the south, here in blue, shelter to the north in orange, and the community facility will be in between them at ground and 2nd floors only. All the 3 programs are designed and calculated to be inside the passive house building envelope. The shelter and permanent housing share floor from ground to 7 levels. And here at 2nd floor, we can see the permanent residential units on the south in blue with a double loaded corridor and the shelter on the west and north in orange. The shelter has a single loaded corridor framed with storefronts to provide lots of natural light and views to the terrace at ground level below. The stairwells of the shelter are wide and are provided with a glazed curtain wall system. These are some of the trauma-informed design features we practice in our designs. The terrace at this level, as mentioned before, is shared by all the residential programs: affordable, supportive, and shelter. This is a design feature that aims to create community and avoid stigmatization. At MAP, we always strive to provide the program adjacencies that foster community building encounters and that provide spaces where people can gather, such as here, where the landscape terrace is connected with the laundry room, the kids' room, and is shared between all the programs. This is a typical floor plan of the residential tower with a double-loaded corridor and apartments with northwest and southeast orientations. As you can see in the floor plan, the central corridor is long due to the density of apartments, but we've designed a central wider area by the stair core and refuse room where the wall and the ceilings, as well as the lighting design, will be a bit unique. With this, we aim to break up visually into sections the length of the corridor, and then at the extremes of the corridor, we're providing windows to bring natural light again and make the views from the tower available to all. Reinforcing the massing and the site placement, we designed the elevator core to be at the southern end of the tower, providing expanded elevator lounges with panoramic views of the river, the aqueduct, and the city skyline. Here we can see a render from those elevator lounges. And this area will, in a typical market rate residential building, be reserved for the most premium apartments. But in affordable housing, there is an opportunity to open it to general use. By making them part of the circulation space, these incredible views can be shared with all residents and not reserved to a lucky few. As a Buildings of Excellence project, our team is committed to provide environmentally responsible material selection, including embodied carbon reduction measurements, such as optimizing the concrete mixes and selecting concrete, steel, and insulation with a publicly disclosed EPD, as well as providing healthy material selections. For the facade, the team is exploring a panelized system as part of our proposal for Buildings of Excellence. We're working with our consultants to perform a thorough cost comparison and analysis of panelized versus site-built facade construction. The research also includes an analysis of site constraints and logistics for procuring, staging, storing, and assembling the panels on site. The alternate site-built facade system being compared is a metal stab backup wall with mineral wool exterior insulation and Roman Emperor brick in black, including, of course, thermally broken connections. The storefronts are provided from floor to ceiling at each of these elevator lounges. And in order to reduce the solar heat gain coefficient to meet the fuse criteria, we have designed this outside sun shading system that's made with terracotta baguettes. In the evening, those elevator lounges will be lit to provide a warm, lantern-like glow for the south end of the property and also the Highbridge Park. And now Sara will be presenting more in depth the systems in the building, electrification, and passive house.
Because of the nuanced foundation design and the city water infrastructure on this site, we couldn't explore geothermal to achieve our electrification of heating and cooling systems. We also wanted to avoid many penetrations in the facade, so we couldn't use unitized heat pumps. So here we have a standard split VRF system. There are two outdoor mechanical rooms, shown here in gray, that are carved out of the residential tower and the passive house enclosure, and air source condensers on the two main roofs as well. The building is separated into 4 zones so that refrigerant lengths are optimized with a mechanical room close by. In all of our buildings, we really want to try to study the layout of these systems so we can minimize the lengths of refrigerant as much as possible. So from these mechanical rooms and the roofs, both the ERVs and the refrigerant lines branch out horizontally and then distribute vertically to serve the stacked apartment layouts. There is heat recovery only on the VRF system in the common rooms and the offices. The rest is zoned by facade to maintain comfort while minimizing refrigerant loads. Passive house buildings open the door to more electrification options that are also more cost effective. When your mechanical system can be so much smaller, unitized options that are coming to our market, such as the APACA, which have sometimes more limited heating capacities, are now really good options. For this project standard VRF split system, because we are a passive house, we don't need hyperheat options for those extremely cold days. Parking is not required in this building, but we have 9 spaces for the offices, and 3 of them will have EV charging stations. All apartments will have induction stoves, and there's solar PV on the main roof. Here you can see a representation of the domestic hot water strategy for this building. The residential tower is served by air source heat pumps using CO2 refrigerant and 3 500-gallon storage tanks, all located on the roof. The wastewater from both the shelter and the residential tower is collected in a holding tank at the lowest level of the building. Water source heat pumps then extract the heat from this 9,500-gallon tank to create domestic hot water for the entire shelter. The actual wastewater itself, of course, flows to the city sewer. So in other words, the shelter source of hot water is the waste heat from the water use of the entire building. This overabundance of warm wastewater will allow the water source heat pump to work quite efficiently. The chart on the left for the wastewater heat pump has a COP steadily between 3 and 3.5, assuming 130-degree output temperature and 70 degrees of incoming wastewater temperature. For most of the year, the wastewater heat pump outperforms the air source heat pump. Only on the hottest days of the year, the warm outdoor air increases the COP of the air source equipment to between 3.5 and 4, but typically it's about 2.75. Here's a line diagram of the Piranha wastewater heat pump system. The team priced out 3 options for hot water for the shelter: this wastewater heat recovery only system, an air source heat pump system only, and a combination of the 2. The system that we chose has an upfront construction cost that was less than the other 2 by 30%, and it's more energy efficient. So here are the performance metrics in green for this building in terms of site and source EUI, and the equivalent carbon metrics as defined by New York City's Local Law 97 for the 2024 to 29 period. The project is committed to FIAS 2021 core certification. So here's the FIAS performance criteria for our building, which depends on project parameters you see here: location, interior floor area, etc., to give us our exact space conditioning criteria for certification. The form factor for this building, or the external surface area to internal treated floor area, is 0.744. So even though this is a relatively narrow and tall tower, overall it has a good form factor. Anything less than 3 is quite workable for passive house. These are the thermal parameters and efficiency targets for this building to achieve 2021 FIAS certification. You can see we don't need any sub-slab or slab-on-grade insulation, and the R values are not that aggressive. In fact, the amount of cooling energy becomes the more difficult parameter to achieve in these dense multifamily buildings. It would have been preferred, actually, that we had less below-grade insulation than required by code. When considering the impact of passive house multifamily construction on the larger grid, here are the key differences in their way their loads behave versus code minimum. Both heating and cooling loads are reduced dramatically, as we all know, but cooling loads are reduced less. They actually use more energy to cool than to heat. Also, the cooling season is longer and will only get longer as the climate warms. On the right are the charts from this project's FIAS feasibility report. The bars in red represent the current design. So you can see we have some adjustments to make to meet the cooling targets. An all-electric multifamily passive house construction uses dramatically less energy and is therefore an important strategy as we work towards 100% renewable grid and electrified buildings. Many of you know that most grids are summer peaking, represented here for New York City on the right. So there's a 42% room for growth of electricity use in the winter. And when we're talking about electrification of building stock, we're essentially talking about electrifying our space conditioning loads for the winter, because they're already electrified for the summer. Even though passive house multifamily is cooling load dominated, it still uses much less energy to cool than code minimum. And they often use split heat pumps, such as this building, which have an integrated energy efficiency ratio of 32, as opposed to window ACs that have an EER of 15. So they use about half the energy in the summer compared to window ACs based on the equipment alone, and then passive house reduces it even further from there. In other words, to serve this building's approximately 300 multifamily units, if we built a code minimum building, we would add stress to the summer grid equaling about 900 units compared to what we're building here. It's ironic that no one raises alarms about grid capacity when someone builds a business as usual building with window ACs, when in fact they can do so much better and cost effectively too. As we work towards 100% renewable grid with all electric buildings, we will truly need passive house design to get us there. There are many studies being done to chart the path forward, but we wanted to highlight this one by Lisa White and Fias, which is being published soon. It's an in-depth study, so I won't attempt to summarize it here, but it does an amazing job of explaining how much smaller and cheaper our renewable grid will be if we focus on improving the enclosures of our new and existing buildings to passive house criteria. And because the enclosure can be carbon storing if we use the right insulation, passive house design is a linchpin in decarbonization. And yet, understandably, there's a lot of hesitation and even fear around electrification. As part of this presentation research, we dove into a lot of the literature, studies, and yes, misinformation out there in New York State specifically that express disbelief in full electrification and decarbonization. We think it's really important to respond to their concerns directly because we have to solve this together, and certain aspects of this transformation are complicated. So here's a list of concerns that we found. I encourage you to think about how you would address these questions, and I'm sure you've encountered many of them before. I think the biggest concern is the cost of a conversion of existing buildings, not for Class A office buildings or even affordable housing at times, because both have market or financial incentives now, especially with IRA. But it's this group in the middle of the market that needs the market to change before it can have cost parity with fossil fuel-based equipment in existing buildings. In new construction, it's already cheaper. But heat pumps are more expensive now in single family conversions, not because they're made of more expensive materials, but because market parameters such as regulation and supply chains and industry knowledge are not fully scaled to the same level as fossil equipment. So one has to be able to see this vision of how the right levers can and will adjust the market so that when it becomes required, it has cost parity. One of the concepts that really gives me hope is that fossil fuel equipment has had 150 years to innovate and has reached pretty much a ceiling. Heat pumps have had 40 years in our market, and their efficiency and their options will only improve, and we are seeing that in real time. Also, heat pumps' power comes from a technology, and since we are not burning anything, we can reach efficiencies well beyond 100%. This is not possible with fossil fuel equipment. Even the best can only reach efficiencies around 90%. So when that energy is burned, it's gone. This industry knows that life cycle analysis and EPDs look much better for solar panels, wind turbines, and batteries than they do for fossil-based equipment. But we still need to make sure that we're extremely careful with refrigerants and that we source our materials ethically and responsibly so that they can and will be recycled. We have already touched upon the important point that we have room on our grid now to electrify, but we need all new construction to be built to passive house standards with its quality control and AirSite verified air tightness testing that will make planning for our 100% renewable grid significantly easier. Thank you, everybody.
Wow. Applause, applause, applause. Feel free to unmute and give these rock stars and sheroes a round of applause. Sara and Lara,
Awesome.
thank you so much. those graphics are so delicious that even if they were meaningless, they would be, you know, a full meal. But they are very meaningful. You shared a lot of lessons learned. And at the end, the call to action is just near and dear to my heart. Sara, you mentioned during the dry run, the amount of time that fossil fuels have had to figure out how to become more efficient versus those that are fossil fuel free. What was it, 250 years to what?
To 40 approximately.
To 40, okay. That's
Well, I keep going.
perspective, that's power. Power
Yeah.
perspective.
I mean, I think the refrigerant cycle was sort of discovered in the 1800s or so, but it really, you know, was like ramped up in the last 50 years. So, because, yeah.
Well,
The magic of
fantastic
phase
stuff.
change. Yes.
Yeah.
Exactly. Thank you so much. Well, we do have a bunch of questions in the queue, and a quick time check. We've got about 20 minutes until we jump into the after hour, if everyone can stay. And we'll take a couple quick cues before we run the sponsor reel, unless Zach, you want to run that now and then take some questions?
Yeah, I'm actually going to do it live. Just a big thank you to the sponsors that make our work at Fast Accelerator possible, starting with our stakeholder partner, NYSERDA, of course. Also, our founding sponsors, a big thank you to them, 475 High Performance Building Supply, Ingui Architecture, Glavel, Minutair, Partel, Rockwell North America, Stocorp, and Solo Windows. And thanks to our champion sponsors, Bowizo, Gradient, Icon Windows and Doors, Intelligent Membranes, PH Air Seal, and Source 2050. And thank you to our patron sponsors, Brennan, Euroline Windows, Holstrom System, Inotech Windows and Doors, Lamelux, Longboard, Owens Corning, RDH Building Science, and Sanderson Sustainable Design. Thanks.
Thank you, Zach. That was awesome. I just threw a spotlight on you real quickly because I think we need to see that full screen every time. Thank you to our sponsors who make everything we do possible. And with that, our first question up is from Angela Hould. I hope I'm saying your name right, Angela. Would you like to unmute and ask your question live?
Sure. And yes, you said my name correctly. I was noticing in one of the vertical kind of sections that you were showing that you chose to mount the PV array above the mechanical equipment on the roof. And I was curious what caused that decision. Was it just space requirements, or is that doubling for shading or amenity space coverage?
Yeah, that's it's to get the maximum amount of space for the PV. We have a lot of equipment up there. We have the entire air source heat pump system for the residential tower, and the ERVs and condensers for the top zones of the tower. Yeah, but we often like to occupy underneath the PV system. We think that's an amazing programming opportunity too.
Yeah, not in this case, but yeah, in many other projects we use it as sun canopies as well. And we're working through the coordination right now as we speak with mechanical and solar panel designer, just making sure that we're within the zoning and making sure that all the space requirements for the equipment are there, and
Yeah, makes sense. Thank you.
ventilation.
Great question, and thank you so much. Our next question up is from Clayton S. Am I saying your name right? And would you like to unmute?
Yeah, hi, it's Clayton.
Clayton, thank you. Nice to meet you.
So I'm not sure if I heard it correctly, but I think you said there was only like 3 parkings in the whole site.
I had a little trouble hearing you. Did Sara and Lara, did you hear the question?
No, can you
It's
repeat?
why is parking not required, I believe.
Oh, it's a transit zone. All the community District 4 in the Bronx, so it's transit oriented. Yeah, parking is not required.
Thank you. And next up is Chris Goodwin. Hi, Chris. You want to unmute and ask your question?
Hi, yes. There's my cat. Just wondering if what types of refrigerants you guys are looking into. I know CO2 is becoming a big thing, but I don't know if it's fit for a project like this or if there's any other ones you're looking into.
There's CO2 for the air source heat pumps for the domestic hot water. But for space conditioning, we're still 410A. I don't think the new one's quite approved yet in New York City. And actually, we invited Dagger Engineering and Josephine, the principal there working on this project, to this meeting. So if she's here, please jump in.
What's her name, Sarah?
Josephine?
Josephine, are you with us? Let's do a quick search in the room while we take one more question in case she needs a moment.
I
Armin?
don't see her on the list. So
Okay, thank you. Well, maybe she was here and we'll come back. Armin, Menendian, would you like to unmute, ask your question? And if not, I can ask it for you. Armin asked at Sara, how do you answer each of the electrification concerns and clarifications? Could you show a slide of your responses to those questions that you asked? And you had one during the dry run.
I did, but again, it got so long. And you would just have a slide of words. Yeah, I think the cost question, I think I kind of addressed. And for new construction, it's especially where it's not, the market's already adjusting for new construction where we do have requirements coming online in a few years. So there is no cost premium there. I think one of them was heat pumps don't warm the air as much as furnaces do, and you need weatherization to do heat pumps. So we're talking about like existing buildings and homeowners, and I in fact know lots of people in the same boat. But you can convert to heat pumps even if you haven't weatherized your building first, but of course that would be preferred. So if you know that's coming, it's a good idea to weatherize. It'll definitely, but you can, if you have to, in this emergency, you can oversize your heat pump system to account for those losses and then downsize later in the future. But the output of the air is what you need in your space. It's not more hotter than you would need to, so you'd have to open your windows as we do in our steam buildings. So
that's great advice. And I think you gave us enough of the answers in the presentation alone. I know I'm going to be referring back to this presentation a lot and sharing it a lot. And I think your message of finding that shared value and figuring out what is important to people and meeting them there with your answers is the great first step. Next question up is John Melansky. Hi, John.
Oh my, hi everybody. I'm a midlife career changer out of aerospace engineering into building science. So I'm a kindergartner here. But I have a home out here near Denver, Colorado. It's not multifamily, of course, but I'm looking at electrification, heat pumps, etc. And so I'm curious just what the state is of refrigerants changes being pushed into code across the country. I don't know what it is in New York, but you said CO2, but R32. Are things moving? Is CO2 good enough for you guys?
I think CO2 has, the global warming potential of 1, and that's our baseline, and so we're good with that with water, our air source equipment for making hot water. But I think if someone has more knowledge about that, I'd be happy to defer, because it's definitely an ongoing transition we're all making. I think Europe is ahead of us, of course. But it's the flammability of the refrigerants is the concern. And also at the same time as switching to better refrigerants, we also need to do better quality control of field connections made on those copper lines. that run the refrigerant. And also in design, minimize their lengths as much as possible. Like we really try to avoid heat recovery because that doubles the amount of lengths in our refrigerants. And we don't really get much energy savings in, most of the time, but we still try to look at it.
How do you study that, Sarah? I know the feasibility study from FIAS that you shared and that secret slide from Lisa was pretty rockin' that you shared that too. Thank you. But how do you go about studying the piping? Does your MEP do a feasibility study, or do they just do the takeoffs and the links and have that best practice perspective?
Yeah, it's pretty, we don't calculate the lengths down to the inch, but we do sort of general takeoffs during schematic design, especially where to place the condensers and which apartments to put on which condenser. And I know Dagger does a lot of
Awesome
on their end too. Yeah.
Thank you. Andrew Peel, I owe you an apology. I believe we skipped you, and thank you, Mary James, for keeping us honest. Are you with us, Andrew?
I am. Yep. Let me see if I can get I don't know if my camera's working.
Good to see you. Happy New
Okay,
Year.
there we go. Happy New Year. Yeah, good to be back. So actually mine's kind of a follow-on from the refrigerant related question with heat pumps. Was whether air to water heat pumps were considered, and a key driver behind that was reducing the amount of refrigerant in the actual building. Obviously, VRF is using a higher GWP refrigerant, and there's, I don't know how many kilometers you might have in such a big building, but it's quite a bit of refrigerant. So, outside of changing the actual refrigerant type, reducing the amount of piping you have that's carrying refrigerant is obviously a key strategy, and very much in keeping with, reducing demand, so to speak, in passive. So yeah, just wondering if you did consider that.
Yeah. I don't have many examples in New York City of air to water for space conditioning. We have a few that are conversions of existing buildings that have low temperature water loops. And then there's a fan coil in the apartments. But I definitely want to get there to hydronic distribution. But I don't know of many examples, and our engineers are not quite comfortable with that. I mean, I would really like that for baseboard, like traditional baseboard heating as well. And I believe it's available. It's just not really uptaking in New York City yet.
Right. And do you have any specific feedback from the mechanical engineers on why they, I don't know if it's a comfort level or experience or what might be there?
We'll definitely get back to you, Andrew. Yep.
Okay, good. Thank you.
Mm-hmm.
Great questions. Great questions. Sean St. Amour, I know you're out there. Would you like to say a few words and take a few questions?
Yeah, for those that aren't in Vancouver, you might be laughing at us because the city of Vancouver shut down with our 3 inches of snow and growing. So as you can tell, I'm prepared. I'm keeping my head warm today because it is chilly. But first off, you know what? I'm glad to be back. Again, Sarah, you and Lara have outperformed yourselves. Love the conversation we've had today. A beautiful building. Renderings are amazing. Presentation is on point. And happy to be back to see all you lovely faces. Hopefully you're in a warm conditioned space and in your comfy seat today. And yeah, the warm coffee and this lovely toque is keeping me warm today. So glad to be back. Love these questions. And I think of just, starting the new year in reflection of just where we began with this whole online environment. And, we were kind of talking about getting into passive house and multifamily, and even 3 years, the level of degree of refrigerant detail and conversations we're diving into is amazing. So love this community, love the collaboration. Thanks to everyone for showing up today. And let's keep the questions going. And if I believe it's Vincent who's up next with Vincent, do you want to pop on?
Yes, I had a question for Sara. I think, Sara, you alluded to renovations and the price of heat pumps for conversions of single family residents still being high, and the need for regulation changes. What are some of the regulation changes that you would suggest to decrease the price of single family residence heat pumps?
Well, I think, in New York State, we have the law for new construction to be all electric starting in 2027 or 2029 for large buildings. Sorry, that was 27 is the city. And it needs to go into the building code. So that was some of the advocacy New York Passive House is doing, is getting that into building code. And I think once the market is comfortable with heat pumps, the price will naturally come down, especially when the market sees that fossil fuels will be discouraged and not incentivized. So right now, the build out of our gas system is subsidized by new consumers. And there's also laws in the state to adjust that as well. And yeah, so it's not made of stuff from the moon. So it's doesn't need to be more expensive.
Great, thank you.
All right, up next is Stuart. So Stuart, hopefully, how much snow do you got in North Van Lines Bay Area?
Yeah, enough to keep me at home, that's for sure. The whole world just decided it was going to be a snow day today, so everything's shut, schools and everything. A quick question for you on the domestic hot water, the choice of sewer heat recovery using the Piranha system. I think it's interesting and a great choice. I just sort of, a lot of people get scared away by sort of the maintenance aspects of that. I'm just wondering, do you have full-time operators in the building looking after the maintenance of that kind of stuff? Or and also the fact that it was cheaper was interesting to me. So I'm just interested to see, your decision process on that and how much cheaper it was.
Yeah, it's about 30% cheaper than a combination or just the air source. And we have the contractor giving us, studying those numbers. So far as I know, there isn't extra maintenance required. It's just water lines, conduit going through the wastewater tank. So I think there's a clean out about once a year of the connection points on the tank. But I'm happy to hear any other specific concerns.
Yeah, no, I mean, I think it's just interesting. We're using it on some of the larger, projects that we have, but on the smaller projects, we tend to sort of, we've shied away from it so far, but I'm just kind of interested to see the experience. We're seeing it in district energy in Vancouver quite a bit, right? Taking that at a larger scale. Yeah, are you using CO2 heat pumps? Do you know which manufacturer that is?
Aegeus, I think.
Yeah.
AGIES. Yeah.
Okay. Interesting. And are the tanks up on the roof, or you got tanks down in the basement?
Tanks on the roof for the residential tower for the air source, and then the wastewater tank in the cellar with the holding tank for the shelter water in the cellar.
Oh, as well. Okay. So are the two systems? Maybe I missed that bit of the presentation. So you got a separate system, you got an air source system for the tower, and then a water source for the lower.
Right.
Sarah, feel free to show that slide again, because
sure.
And Stuart, while she's maybe pulling that up, if you don't mind, what are the maintenance concerns outside of the clean out once a year that you were thinking people shy away from? I'm just curious because you both work in this space so much more often than I do.
Yeah, it's just that you're intercepting, sewer water, so it's black water, right? With everything in it, and things can get clogged up. And there are two systems, right? There's the Piranha system, I think. Then there's the Shark system. I think the Shark system has like a macerating pump in there that's obviously designed to deal with sewage, but at some point somebody's got to come in and deal with that, And if you've got sort of building managers and stuff that changing light bulbs and stuff, that's a much bigger system and a much more. But I think the Piranha system is just in a tank, right? So it's like a heat exchanger in a tank, but I think you do still have to clean it out, right, to make sure that heat exchange still happens, right? So if once a year you've got to get involved with black water and all of the bacteria and other stuff in there, it's something that people need to consider, right?
I'm sure they've received that question and have probably mechanized ways of handling it. it's definitely something we should be able to explain off the tip of our tongues here.
And it's great intel. And if you have a link you can throw in for the system that you're talking about, I'd love to do a little more research. We're on wells and septic over here. We deal with that stuff all the time. And 30% is a lot for a once a year maintenance. That 30% savings is no joke. And attacking this water problem it's got to be done. So we really, thanks for being brave on this project. And Stuart, thanks for, asking some better questions than I would know to ask. Next person up is Jay Waterman. Jay, are you with us?
Yes,
Wanna
I am.
unmute?
Hi, in Portland, Maine. Quick question about the cooling centers that you mentioned at the beginning. Often we have, when we are able to put cooling in the units, we don't necessarily have cooling centers. I'm wondering what your cooling center strategy was, and does it support the surrounding neighborhood?
Yeah, so the cooling centers are a resiliency feature, meaning when the system might go down, those are powered by the generators. So it's up to the owner to open it to the neighborhoods or just for the 1,000 residents of the building. But yeah, that's still TBD, but that's kind of the main purpose.
Great stuff. Okay, next in the queue is Gall. Gall Spanner, over to you. And I'm just checking to see.
Yeah, is
Yep.
Gala here?
If not, we'll head
He
over to.
is, but he's
Oh.
muted still. So maybe he can't ask and we should ask for him.
I gotta find it.
It says, having solar as canopy ease maintenance and cleaning of the panels and separates their life cycle from the life cycle of the roof. I don't know that that's so much a question as a comment, but it's a good subject that we already touched on a little bit. Is there anything else you wanted to say about it, Lara or Sarah?
No, I think that story, right? We're always looking at something that is long lasting. So, in the future, that steel canopy can allocate all the different sizes of panels and, just stay current.
Yeah, I mean, I saw that first system over at Tim McDonald's project in Philly, and then now seeing other things, it's great how we're again stealing and again copying is a form of flattery, but seeing those kinds of things being put into different projects is so cool, and great to see it being incorporated in this particular project.
And as great artists know, you're not stealing if you make it better.
And of course,
that's your obligation. If you're going to take, you have to improve.
That's it. And of course, flattering is with the PH. Carmel, over to you.
Thanks. I had a question about what some of the non-negotiables were going into this, either feedback that the community gave or the owner gave that either helped you make better decisions or caused for more of a pause and a analysis on a challenge to making the better decision.
So I think one aspect is, we explored a wider and shorter building, but that actually took up more of the views from the neighborhood. So that was some part of the extensive community engagement feedback. And we've set it back from the street even more than the existing building. And there's a lot of landscaping, and getting access to Bridge Park is extremely important. Lara, is there other answers you have for that?
I was wondering is the question related to maybe sustainability features of the building or just in general? I think in terms of non-negotiables from the community, I think, one concern the community had was the height of the building, which is as of right. So we developed a couple of alternative options. And yeah, as Sarah mentioned, they all cover more of the view of the park as opposed to this option that it's a massing that is taller and farther setback, same floor area than wider and kind of like chunkier massings. But in terms of other decisions, I think not non-negotiables, but I think it's great that we've analyzed all the systems, you know, with a pricing from the GC. We've always had the GC on board to assist us with, you know, constructability of what we want to propose, and we're getting a lot of data from all our consultants and the GC, and, you know, on the facade systems and this prana analysis versus other options for the hot water system. Yeah, it's just, I think, yeah, we've done a lot of comparative analysis. I don't think we've gotten a non-negotiable, except, you know, price and yeah, feasibility. So yeah.
Thanks so much for that question. And where are we now, Sean? Who's up next? Is it Scott?
Yeah, we'll go over to Scott. It's not maybe a project question, but happy to help out, Scott. Go ahead and ask it.
Scott, are you with us?
Yeah, he's there. There you are.
Hey, I'm very much a novice, but I've been following passive home for 3 to 4 years and very, very interested in it. And I have an 1840 home that we were trying to do and in passive, and pretty much just got snow blocked. But it just doesn't seem like solar is really an option in Ohio. And I was just curious to know if you could give me more information. Because I wanted to do Tesla shingles, and that's, you know, pretty much non-existent. I didn't want any panels on my house, and I just, you know, wanted to see if because I don't see a whole lot of it around at all.
Good question, Scott. Thank you.
So I think you might want to look at community solar, which could be through your utility provider. Many people can sign up to basically get their power from the large solar in your nearby.
That's what I do.
What about I just sent the mayor of a local town on a LinkedIn some information on a solar farm, and because it just seems like that would be, it's kind of an underprivileged town, and it seems like that would be a really great source for him to, you know, bring up. But would that also be something you'd contact community solar through?
Yeah, actually community solar is more of like as a concept, and and then the solar farms is the other word for a large solar array. And your utility provider might even offer this option already. But for example, in New York State, I'm sorry, I don't know exactly how things are going in Ohio, but we have NYSERDA, our New York State Energy and Research and Development Authority, helping smaller communities find community solar projects and get people signed up. And you can actually get points for being doing some of these things, including installing EV chargers and, you know, all the aspects we need to get us there. And I'm sure your state probably has some, and a lot has been initiated through IRA. And so if your state wants to take advantage of federal funds, they need to kind of set things up like that, like we have in NYSERDA. I'm not sure if you have a public benefit corporation in Ohio that manages stuff like that, but you might.
Okay, well, thank you.
Yeah, that's a great question and a great subject in general. And, you know, we've got smaller buildings that want to think like these big projects and source their energy in a renewable way. And I know in Pennsylvania, like Ohio, we have, you know, a lot of struggle trying to get community solar advocated and accessible. But we do have great providers who will sell it to us from renewable resources, which is awesome.
Yeah, Scott, thanks for joining us again. Thanks for being a novice. The people here, there's lots of great resources, so keep coming back and look at retrofitting first, looking at air tightness, caulking windows, start with the basics before you have to put on a big solar array where again, working on your shell would be a best start. But also tell your mayor, there's a big giant parking lot, I'm sure, that could have a lovely solar array on top of it. And it's a good way to send a message to the community by putting one right at the mayor's office. So
Yeah, and reaching out to your local community is totally the way to go when you're trying to organize kind of a collective microgrid to go with the nanogrid you're trying to do at your house, right? It takes a village, and you start in your own village if you can.
And look at Zach's already giving you some info.
To redo it was an old bank building they're getting ready to redo into a city office building. And I sent him some concepts of some covered parking spaces with solar on top that so for some ideas. So
those are great ideas, and they can put the chargers right on them too. Yeah.
Right.
Who's
Okay,
next,
thank you,
Sean?
thank
Do we
you.
have is it Ryan?
Yeah, we got Ryan and Kevin, and then we'll see how we're doing for time here, because we're getting close to the end of the final 15. So Ryan, over to you. Thanks, Scott.
Hey, Sarah and Lara, that's a great presentation. And I have two questions. One is from one of your rendering. I noticed the exterior shading. Is that really used to in the design? And if so, how much impact it's helping the reducing the cooling load and demand? And my second question is this the wastewater heat pump. It looks like you collect the whole building wastewater to serve the small portion of the building. Is that due to capacity issue? That's my two questions. Thank you.
Take the hot water, and Lara, maybe you want to take the terracotta baguette shading. So we needed a source of waste of hot water essentially first. Like, so the air source heat pumps need to create that really hot water for the tower, and then so we needed that. So we actually have a lot of wastewater, a lot of heat that's being wasted through that system. And so I think the tank and the wastewater heat pump recovery system could be even larger to serve more of the building. But we're sort of taking a conservative approach, using some of the hot water from the air source to serve part of the building too.
Good to hear. And in theory, do you have the number that how large of the portion of the building that system can serve?
It's sort of like a chicken and egg thing. I mean, you need the air source part. So where that threshold is, it's yeah. I mean, I think it could be sized to be as large as you would need it for whatever project you would need it for. But you would need a source of hot water as well. Other one.
So it depends.
Gotcha.
It depends.
It depends. Lara, do you want to talk about the terracotta shading? I'm super curious about that too.
Yeah, so I'm exactly not sure how much of the demand without them we will have, but we did a Wi-Fi passive energy model for the facade, including those. And yeah, it will be interesting to know how much it will vary without them.
And did you iterate on that design and like add a little more or take a little away? And obviously you were preserving views while shading. So, and that must have been a really fun design exercise to incorporate Wi-Fi into.
Yeah. 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 I think we might need more interactions for that. Just, as of now, we're currently complying to all the criteria. I think we're a little bit, Sarah, correct me, fine. We're a little bit above the cooling demand, right?
Right, and I think it's because our lighting modeling isn't finalized yet and refined. a lot of internal gains from lighting.
Well,
Oh, okay. We
cooling
have
dominated, right?
we
Yeah.
have Carmel from Bright Power is actually responding to the WUFI model. They didn't account for the Bright Power is our energy consultant and passive house consultant. So seems like they still didn't account for those. So we're targeting meeting that without them first and then optimizing it down once the locations are finalized. So yeah, we still
Thank
need some
you.
refinement, but yeah. Okay.
I love that. So that's like buffer that you haven't even tapped into yet in that model. Buffer matters. Thank you. Last question, right, Sean? Do we have time?
Well, technically you asked one, but we'll see. But we're kind of over time. I think your question could turn into a whole presentation at a future, Pasos conference. But Kevin had a comment. He is in a noisy cafe, so he gave me the opportunity to share it. And maybe a good way to kind of wrap up our day here is the term resilience, making buildings resilient. And his kind of comment was just talking about, could you expand on the cold and hot peaks? Because he is in Alberta where it was minus 40 C and F is the peak cold. And yeah, it's going to be cold with in Alberta and some other places in North America. As the Arctic outflow is the new phrase of the week. He last year was polar vortex. So maybe want to just share kind of how you guys have looked at resiliency in this tower.
Yeah, I mean, we know that if there's no heating and cooling and it's very cold, the people in a passive house building are going to be more comfortable for much longer. And I heard some earlier on this in this presentation today that people are in some very cool climates right now and their heat is not on because they are in a passive house. You can, in the summertime, you can open the windows at night. I think that's one strategy we don't, common sense that we also need to kind of fold into that larger resiliency question. So yeah, I mean, if you're concerned about resiliency, build a passive.
And
I
there
don't think it can be said
Good
better
advice.
than that.
That's exactly it. I mean, I know for myself, seeing Trey Farmer's presentation on his passive house in Texas a couple years ago really made me aware of that phrase. I had friends' pipes burst on Saturday and was fixing them because of just Vancouver temperatures are really pushing climate zone 4 here today for this week. So again, just be aware of things. And as you said, build or retrofit to a passive house. So Shannon, any final words? Otherwise, we'll give it over back to Kim and Zach to hit the ejection button, and we'll see everyone next week.
It sounds brilliant. Be aware is another good tagline. Be aware of the events coming up and check out our website. Sign up for Reimagine Buildings 24. Reach out to connect with us, and please thank our speakers on LinkedIn. Zach, any final words?
No, thank you, Sarah and Lara. That was amazing. Really appreciate it.
Thanks, guys.